Okay, so moving on to Chapter 8, Lesson 8.1 talks about the law of sines. So this is something that you should have seen in geometry, especially if you were in the geometry honors class. If you were not, I'm not sure if you guys saw this or not, so I'll just pretend like it's brand new, okay? So the law of sines is for oblique triangles, which are non-right triangles. So we have a triangle that maybe looks something like this, and you're looking at, vertice A right here is, I'm going to call that alpha, angle alpha. And then vertice B right here, I'm going to call that angle beta. And then this would be angle gamma. And if you notice, right across from that angle alpha is side A. Same thing here, right across from angle beta is side B. And then angle gamma matches up with side C across from it. So I'm saying that because the law of sines tells me I can match up those sides together, and if I take the sine of that angle and I divide it by the side that it matches up with, that will be equal no matter which angle and side I use, as long as I'm matching them up across like this. Okay, so a lot of the time you will see them say solve the triangle. What that means is find all the missing parts. Typically they will give you 3 pieces and you will have to find the other 3. 3 sides and 3 angles is what we have total. So if they give me 1 angle and 2 sides, then I need to find 2 angles and 1 side and so on. Okay, so in example 1 here, I'm going to start with an easy one. So this one tells me to solve it, and they give me 2 of the angles and 1 of the sides. So I'm just going to sketch out a very generic sketch. It is not going to be to scale. It's not going to be correct. I'm just going to give myself a triangle, and I'm going to call it ABC, and I'm going to start labeling what they gave me. So angle beta, which was this angle right here, is 25 degrees. Angle gamma is 41 degrees. And then side B, which is across from angle B or angle beta right there, is 170. So I need to find these 2 sides and this angle right here. So the easiest one right now, if they give me 2 angles, I can find the third one by subtracting those from 180. So I'm going to go ahead and do that. That's my easy one. So I'm going to take my 25 and my 41, put them together. That gives me 66. And then I'm going to take my 180 for a triangle and subtract that 66. That gives me 114. So this angle right here is 114. I would always label these according to alpha, beta, gamma, and then side ABC. So this one is angle alpha. And I need to put my degrees on there, sorry. Okay. So then how do I deal with the sides? Because it's not a right triangle, I can't use Pythagorean theorem or anything like that. So instead, I'm going to use this law of sines. So let's say I definitely know this one and this one, they match up together, right? So if I'm going to use law of sines, I for sure have to use that one. So I'm going to go ahead and write that one down. So the sine of the angle over 170. That will give me the sine of the angle. So let's say I go with A first. So sine of 114 over side A. That's what I'm looking for right now. I could have also said the sine of 41 over C. So now I'm going to cross multiply and solve. So this would give me A times the sine of 25 degrees equals 170 times the sine of 114 degrees. So A is going to end up, if I go ahead and divide by the sine of 25, so A will be 170 times the sine of 114 divided by the sine of 25. So I'm going to find that on a calculator, and then I'm going to round it. So let me show you real quick how that works out. So the sine of 114, I always work kind of backwards. So I don't type things straight into the calculator because I'm just, I don't know, kind of weird about that. I always feel like it's going to be wrong. So just in case. So I'm going to do the sine of 114. And something I should have done was made sure I'm in degree mode, which I am. So the sine of 114 is that, and then I'm going to take that times my 170, and then I'm going to divide that by the sine of 25. Okay, so I'm getting 367.48. Now, sometimes they will ask you just to round to a whole number. Sometimes they will say round to a specific place value. They didn't in this one, so I'm just going to put 2 numbers after the decimal because it makes me feel a little safer. Okay, the next one, so once I have this side, so that was this one right here, so I've got it done. This is the one that I need now. So now again, I'm going to use these 2 because that was given to me at the beginning. You could use these 2 as your 2 that you know, but I have to know 3 out of the 4 things. So I've got 2 of those, and then this one, and this is the one I'm missing. So I'm going to do the same thing I just did, sine of 25 over 170 equals, this time I'm going to do the sine of 41 over whatever C is going to end up. So C will be my 170 times the sine of 41 over the sine of 25. So I kind of squeeze that in there. So C is about sine of 41 times 170 divided by the sine of 25. I'm getting about 263.90. Okay, so now I've solved the triangle because I have these 3 pieces and they gave me 3 pieces, so now we know all 6 of them. Okay, this second one, so this is where I start to get a little bit nervous. If they give me just one angle, I want you to think about what this looks like. So let's say I have this triangle that looks like this. So this is one possible triangle that I could have, right? So this angle right here is, I don't know, let's say that angle is 20 degrees. Okay, well, it is possible that this could be the triangle. Or this side right here could swing out and look like this. And then you would have a totally different triangle, right? So this side right here and this side right here are the same. This side over here would stay the same no matter which one I'm talking about. So whether I'm talking about this triangle or whether I'm talking about this triangle. Oh, that was a really bad drawing. There you go. It doesn't matter. Like this could happen. So this side right here could swing out and be over this way because that's the same length. This angle would still be the same. So the issue that we're having here is you could have 2 possibilities where this angle is 20 degrees. So if they only give me one angle, say 20 degrees, I have 2 things I really need to look for. And I'm going to show you a really easy way to do that because this angle right here and this angle right here, we have kind of a relationship between those. They equal 180. So we'll talk about that in a minute. Okay, so first let's look at this one. That was not an issue in this one because I knew 2 of the angles already. So like these 2 angles were kind of set. I just needed to find the third one. Something else that I'll throw out there, back in geometry, you learned all about side angle side and angle side angle and angle angle side. One thing that was always avoided by teachers is angle side side, which is what we are dealing with now, and it was avoided because it's angle side side. It looks like that. So these are the triangles that we always avoided, but these are the triangles we're talking about when we talk about the law of sines. All right, so example 2 here. This one they gave me 1 angle, 2 sides. So again, I'm just going to sketch out what that might look like. So ABC. So my angle alpha is 27 degrees. My side C, which is across here, that's 75, and my side A is 34. So there's my triangle. And then I'm going to use sine of 27 over 34 equals, I don't know this one, so I'm going to say the sine of, I could say C or I could say gamma. This one right here would be gamma over 75. So I just matched those up. I can't do what I did here because I don't have two of the angles, so I can't just subtract from 180. Okay, so this one gives me 34 sine of gamma equals 75 times the sine of 27. So the sine of gamma is going to be 75 times the sine of 27 all over 34. So I'm going to have to use an inverse sine to find this one. All right, so if I do the sine of 27 times 75 divided by 34, I get this. Okay, so this is going to be an issue, and I'll show you why. So the sine of gamma equals 1 point, I'm just going to say, let's see, 001. Let's just go with that. So it's about 1.001. Okay, now to find just this angle, you would have to do an inverse sine. So I'm going to do an inverse sine of both sides. That will get rid of this sine, and it will give me just gamma. Okay, so I'm going to do an inverse sine of that value, so that answer. And it gives me an error. I wonder why it gives me an error. So here's why. Do you remember that when you do inverse sine, so we've talked about it up here on this set of notes, when you do an inverse sine, you can't if it's outside of this domain. So that's an issue. This one was at 1.00 something. That's bigger than 1. So that can't work. So in this situation, no triangle exists that has those dimensions. So this is not possible, in other words. Okay, so in the next video, I will talk about, actually, I'll just keep going. It's not too long of a video, and this is the last example we've got, so I'm just going to keep going. All right, so example 3. This one, again, they only gave me one angle, so what I'm worried about is this situation right here, but I'm going to set it up again just like I did that last one. So I've got my A, B, C. Angle A is, this one is 27 degrees, 30 minutes. So what does that mean? That means 27.5 degrees. So I would change those, but our answers really need to be in minutes. Okay, and then side C is 52.8, side A is 28.1. All right, so the sine of 27.5 degrees over 28.1 equals the sine of gamma over 52.8. So the sine of gamma is going to be 52.8 times the sine of 27.5 over 28.1. That was really messy. I apologize for that. Okay, so I'm going to do the sine of 27.5 times 52.8 divided by 28.1. So I'm getting this. Okay, so now this is where it gets kind of tricky. So first, let's talk about, let me go ahead and finish this out. So that's sine equals, and I'm going to say it's about 0.86, I'm going to go 868. All right, so now I need to get this actual angle. So this is between -1 and 1. That's awesome. Now I need to know, well, what is gamma? Okay, so I'm going to take the inverse sine of both sides to make that happen. I'll just take my answer and do it. So I'm getting about, let's call that 60.18. Let's just go to the 10th place. So I need to find this first in minutes because that's what it was given to me in up here. So if I look at any type of an answer key, it's going to give it to me in degrees and minutes. So let's make this minutes. So 60.18, if I take this 0.18, multiply it by 60, that would give me 60 degrees, and then 0.18 times 60 is 10.8, so I'm going to say that's about 11 minutes. So I'm rounding. Definitely in the back of the book, so let's say they had 60 degrees, 12 minutes. You did the right thing, you just probably rounded differently. So just be careful and know that it's okay. Okay, so now the issue is I have to find the other possibility. So what I just found was, let's see, if this one's 60, I just found this one, this possibility. I need to find, well, what if this was swung over and I had this one? I want you to think about this. This angle right here and this angle right here are the same because this is an equilateral triangle. I am not even showing you. Okay, there we go. This angle and this angle are the same because this is not an equilateral, I'm sorry, but these two sides are the same, which makes these two angles the same. So then, what do I know about that relationship? So remember what I said earlier, 180 minus this one would give me this one. So if I take 180 and I subtract this from it, I'm going to get that other possible angle. So to get the other one, I can just say, well, what is 180 minus, in this case, it was 60.18, or I could have said 179 degrees, 60 minutes, minus 60 degrees, 11 minutes. Either way, I'm going to end up with 119 and 49 minutes. So I put it in minutes already. So here's my other possibility. So I have case 1 right there, and this is my case 2. So I have 2 possibilities here. So if I go with case 1, in case 1, my gamma is about 60 degrees, 11 minutes. So I've got that one. In my case 2, my gamma is about 119.49 minutes. Okay, so now I need to find the rest. Well, if I have 2 of the angles, which I do now, then I can find the third by subtracting from 180 because a triangle gives me 180. So I knew my first angle was 27 degrees, 30 minutes. And this one is 60 degrees, 11 minutes. So if I add those together and then take it away from 180, I'll get what I'm looking for here. So 87.41. So then here's how I write it. I say, instead of saying 180 degrees, I say 179 degrees, 60 minutes, which is the same thing. And I'm going to subtract that 87 degrees, 41 minutes. All right, so that gives me 92 degrees, 19 minutes. So that's going to be my third angle. So they gave me alpha up here. I found gamma here, so this one is beta. And I can do the same thing for this one. So my 119.49 plus the 27 degrees, 30 minutes that they gave me at the beginning of the problem, 146.79, which is weird. So this is the same thing as saying 147.19. So 60 minutes, I had too much, right? So I can go ahead and carry that one, I guess you could say. Okay, so then I need to take my 179.60 and minus my 147.19. Okay, so that gives me 32 degrees, 41 minutes. So that's the beta in this case. So I have 2 cases here. I'm kind of solving them simultaneously. Okay, the last thing I need to find, I found all 3 angles now, and I have 2 sides that they gave me. I just need to find side B. Okay, so I'm going to use the sine of, let's see, which one do I want to use? It doesn't really matter. So let's say I use just this original case they gave me. So 27 degrees, 30 minutes, and side 28.1. So 27 degrees, 30 minutes over 28.1 equals the other side. So if I'm looking for B, my angle beta is one of them, so sine of 92 degrees, 19 minutes over side B, because we don't know that. And I'm going to do the same thing over here. For this case, I would be doing, I'm going to leave that my 27 degrees, 30 minutes over my 28.1. That's going to equal, in this case, the sine of 32 degrees, 41 minutes over side B. So again, convert these to your, just a decimal, right? So this would be 27.5. Go ahead and do that. So divide it by 60. And then solve that out. So in this case, I ended up with B being about, so this was calculator work. I'm just going to let you do it. I got about 60.8. And then on this one, I got that B is about 32.9. And those are sides, so I'm okay with leaving those the way that they are, just decimals. Okay, so if they ask you to solve the triangle and you're given only one angle to begin with, it's possible that you could end up with two cases, so you're going to end up with 6 answers instead of the normal 3.